Hi everyone, Megan Zimba for Wireless Design and Development. We're here at IMS 2014 in Tampa Bay, Florida. I'm here with Joe Mezzaket, General Manager for Eastern Optx. Why don't you tell us what you got going on here today?
I'd be happy to, Megan. Eastern Optx is a manufacturer of radar test equipment for distance radar systems, surveillance systems, radar altimeters, and also communication networks. So we have demonstrating here today a system that will produce the appropriate propagation path delay that you'd expect to see between a target and a radar system, and also the added Doppler shift that you'd expect from a moving target. So together, those two components will give a full scenario for either a flight of an aircraft, the movement of a ship, the movement of a land target, and at the same time introduce the typical propagation path disturbances that you'd expect to see, like clutter and multipath, any other kind of interference that you'd expect to see in the real world.
So what would you say is the main problem that you're helping your consumers solve with this product?
The key problem is to reduce the amount of field testing that's required to either qualify a radar or to verify its performance after some kind of a problem, or in the development phase. If you can reduce the field testing, you can reduce the cost and reduce the time to market for the radar system.
So then, in your opinion, what would you say is one of the top features of this product that sets you apart from your competitors?
Well, even if field testing is the selected alternative for performing this kind of test, there's rarely any opportunity to optimize performance. Once you're in the field and you're performing the test, if you're successful, it's usually a good stopping point because it's so expensive and so time consuming. If you're in a laboratory environment that's controlled and you can use a system like this, you can take the time necessary to make the changes required to improve the performance. Maybe there's a problem with the system, you can troubleshoot it. It's very difficult to troubleshoot a live system, particularly if it's on board an aircraft or on a ship or even on a land vehicle.
Is that something you're able to do with your product?
Absolutely, because the environment that we create, it's the real world environment, but you're performing it in a controlled space, in a laboratory, at a repeater site, somewhere where you can take the time necessary to really troubleshoot, really figure out why this thing is behaving the way it is, or you've achieved the initial requirement, but how much margin do I have in that design? Is it just on the edge, or do I have an extra 30 dB of range? This system will let you determine that, because you can take the time in the laboratory and figure it out.
Well, thank you, Joe, for having us here at IMS at your booth. We appreciate the time. For Wireless Design and Development, I'm Megan Zimba, and we'll see you next time.